Questions from worksheet 1? A bunch of algebra stuff, starting at like even number 4. And then there's some equations on the back. So let's do something from 4 through 11. Anything on there that number 9. Right. Again, we don't take derivatives of roots, and we don't take antiderivatives of roots. We would much rather rewrite that as a power. So that's a good one to ask, Brooke, because that one's got a power, a root, and it's in the bottom. So how could you rewrite the 5th root of x cubed in the denominator? What exponent would that be?
5/3.
Which one? Negative because it's in the bottom. You guys don't know the little picture, right? The flower power grows on top, and the root grows underneath. Flower power, root. So which one's in the top? 3. The power's in the top, the root's in the bottom. So x to the negative 3/5 plus x minus 1. dx means which variable are we looking at to antiderivative with? Okay, so increase the power by 1. Negative 3/5 plus 1? 2/5. And then divide by 2/5. But that's the same thing as multiplying by 5 halves. And if you ignore that 2 there for a minute, that makes sense, because if we took a derivative of 5 halves x to the 2/5, we'd bring the 2/5 down, it would cancel the 5 halves, we'd decrease the power by 1 and be back to negative 3/5. So these sort of check themselves as you go if you'll take the time to make sure. We could clean that up a little bit in a minute, but we don't have to. Alright, that's x to the 1st, so if I increase the power by 1 and divide by the new power, x squared over 2. And then in some ways the last number is easy because you can think about it and figure it out, and in other ways it's hard because it doesn't seem like it fits the pattern because there's not a power there. But what's the antiderivative of negative 1? Like, what would have a derivative of negative 1? Negative x plus c. And you could leave it like that. That's fine. Obviously, those 2's could cancel. You could get fancy and write this as the 5th root of x squared. But you also don't have to do any of that. You could leave it like that. Abby. 16. Uh-oh. That's probably one where we're going to have to find c. No. Oh, I'm glad you asked 16. Because after making the test for this unit over the weekend, number 16 will make an encore performance next Tuesday. There you go. Okay, so what does that mean? That symbol, what does this symbol mean? That elongated S? Antiderivative. And what about that little thing? What does that mean? Derivative. So I've got the antiderivative of a derivative. So those sort of cancel each other out. So it's definitely not a second derivative. And it's not still the first derivative because we antiderivative that thing. And then, I've got f of x. I like that part. So is it c or d? C. Because if you take an antiderivative, a c might show up, or does show up. F of x plus c. How about something from 12 through 15? Then we'll hit a little bit of everything. 15, just because it looks hardest? Fair enough. 15. So the second derivative, it gives us the second derivative, and then gives us some information. Do you remember why it gives us this information? What are we going to use that for? To find C. Because when we antiderivative, a C shows up, but they've given us stuff to figure out what that C is. So if I antiderivative both sides, on the left, the antiderivative of the second derivative, so I'm canceling one derivative, that gets me back to one derivative. On the other side, increase the power by 1. Here's where our little fractions and negatives and adding messes people up. It's not going to mess James up, though. James, if I start at negative 3/2 and I add 1, what does that land me at? Negative 3/2 plus 1.
Negative 3/2 plus 1.
Mm-hmm. Negative 1/2. Right, there's my calculus is easy, algebra is hard stamp. Know the rule, but can we add fractions? That's not even algebra. Like calculus is easy, fractions are hard stamp. Plus C. And then we'll plug in this first one. Uh-oh, what did I mess up? Oh yeah, I did the increase the power, but not. So what's my coefficient need to be? Negative 2? Because I'm dividing by negative 1/2? Or sometimes people just think, well, what does my coefficient need to be so that it cancels out? So negative 1/2 times negative 2 would go away, would cancel each other out. Because again, you either follow the algorithm of increase the power by 1, divide by the new power. The other algorithm is increase the power by 1 and figure out what the coefficient needs to be. That's a little less formulaic, but some people could just figure it out. Okay, now I can plug in this point. So the answer is 2. When I plug in 4, I don't want to do 4 to the negative 1/2. I'd rather negative sends it to the bottom, and 1/2 is a square root. So let's see. Negative 2 divided by 2 is negative 1. So C equals 3. So G prime is negative 2. I'm still going to leave that as x to the negative 1/2 because it's easier to do derivatives and antiderivatives with exponents than it is with roots. So it's easier to calculate with roots, but for derivatives and antiderivatives, I want the power. Okay, halfway home. We need to do all that same process again because we want to get back to G, and I'm only at G prime, so I need to do an antiderivative of both sides because the antiderivative of a derivative gets me back to G. And then, let's see, who do we trust with fractions? Trust Ava with fractions. Ava, if I start with x to the negative 1/2, if I increase the power by 1, what does that get me? It'd be 1/2. And then I need to divide by 1/2, so that'd be multiplied by 2. And that negative 2 is still there. Increase the power by 1, divide by the new power. Avery, how about the antiderivative of 3? 3x. And then we don't forget the plus c. Usually students don't forget the plus c on these type of problems because they know there's, like, otherwise, like, why is that there? It's so that you can figure out what c is. Okay, so g of x is negative 4x to the 1/2 plus 3x plus c. I plug in 0 to get 0. I get 0 plus c. So C equals 0. Again, sometimes this confuses people because, wait, is C equals 3 or does C equal 0? It's like, well, it depends on which part of the problem. If that bugs you, then you call this second one C2, and then you don't have to worry about getting confused on who's who. But most of the time you do them one at a time, and so you sort of clear it out and then start again, and it's fine to use the same letter for two different things. So my final answer then is negative 4x to the 1/2 plus 3x. C2 is 0, so I don't need to rewrite that. So there's my answer to number 15. All right, let's look at worksheet 2. Today's assignment, worksheet 2. No new rules. Like I did all the rules on Friday. So this one has trig functions and exponent functions, but we've done those. So let's just jump in and do some of these together. In fact, why don't you do 1 through 6 really quick? That'd be a good review of your trig rules. So turn to worksheet 2 and do 1 through 6. Okay, so what else do we need to look at here? The rest of those are just like combinations of things. 11 and 12 looks like we need to use some trig on those. So why don't you skip down and try 11 and 12. And remember, there is no quotient rule, so I have to do something first other than quotient ruling that. So what's 1 over cosine? What's that the same thing as? Like, what's another way to write this? Secant squared. And then you'll do something similar with number 12. So try those two. So there's the answers to 11 and 12. But let's skip down to 15 and 16. I have not done those, but it's still thinking backwards. So I'm not really worried about the 7. What function has a derivative of, again, I'm just thinking backwards. What function has a derivative of e to the x? E to the x, that's the weird one. The derivative of e to the x is e to the x. That means the antiderivative of e to the x is e to the x. So the 7's still there. The antiderivative of e to the x is e to the x. Don't forget the plus c. But 16's got a 5 on it, so maybe we should think about, right, let's remind ourselves how to drive forward first, and then we'll worry about driving backwards. So forget the antiderivative. What's the derivative of 5 to the x? I mean, there's sort of a hint in those answer choices, maybe. 5 to the x is part of the answer, times natural log of 5. Okay, so the antiderivative means do the opposite. So I need to think backwards. So of those answer choices, which one do you think that you could throw out? Somebody throw out one of them. What's it definitely not? Which one? What are you throwing out? D? Yeah, good. Throw out D. That's like trying to use that the power rule. But the power rule only works if it's x to a power, right? The antiderivative of x to the 4th is x to the 5th over 5. But you don't do that with x's. So yeah, D is out. A, B, and C all have a 5 to the x in them, which makes sense because the derivative of 5 to the x is 5 to the x. So that checks. But when we take a derivative, we have to multiply by a natural log of 5. So if we take an antiderivative, I think I can throw A out. I've got to do something with natural log of 5. So do we think it's B or C? C, because it's the antiderivative. So instead of multiplying by natural log of 5, we'll divide by natural log of 5. Another one of those where the better you know how to drive forward, the easier it is to drive in reverse. Let's see. How about 17? Why don't you try 17? Let's see. 18. Let's see. Let's pick on people just straight from the get-go here. Holly, how about that first term, the antiderivative of 2 to the x? 2 to the x over natural log of 2. Right? Because the derivative is 2 to the x times natural log of 2. The antiderivative is divided by natural log of 2. Jameson, how about the antiderivative of e to the pi? What kind of number is e to the pi? Is it a constant or a variable? Does it have x in it? No. The e to the pi is weird, but it's just a number. It's just a constant. The derivative would be 0, but the antiderivative, let's see, let's back up. What's the antiderivative of 3x? Anybody? What's the antiderivative of 3x? Excuse me, gave away the answer. The antiderivative of 3 is 3x. How about the antiderivative of 72? 72x. So Jameson, how about the antiderivative of e to the pi? You said that in the wrong order. E to the pi times x. Because e to the pi is just a number. A weird number, but just a number. A constant. So let's see. 2 to the x over natural log 2. So answer choice B. Again, the rest is just more practice. So I'll stop there. But your job is to finish worksheet 2. Tomorrow we'll do kind of the same thing with worksheet 3. I'll answer a few more from worksheet 2. We'll do a few from worksheet 3 together. There's nothing new on worksheet 3. It just tries to jumble them all up. Mixed antiderivatives. But yeah, it's just more practice on driving backwards. So we did all the notes Friday. And then Friday, Monday, Tuesday, practice, practice, practice. And then we'll add rectangles on block day.